So this example here is very illustrative of how questions and their wording can sort of throw you off. We're given a reaction here, and we're asked if if a particular amount of grams of a particular compound reacts with another compound, how much product is formed. And that product, of course, is yet another compound. So in this case, it's if 2 grams of V2O5 react with HCl, how much VOCl3 is formed? And the idea is to sort of recognize that this is much of the same process, except we're sort of dodging a couple attempts that the question has thrown our way, of sort of confusing us. So, you'll recognize as part of a very established drill by now that you start with what you want. And so one of the first things you should write down is what you want, or what you're given to start with, and what you want that to be expressed as something. So 2.0 grams of V2O5, right? That's what we're starting with. And we know that we're going to have to extend our chain of conversion factors and sort of dodge through, work our way through intermediate conversion factors to eventually get to somewhere we know answers our question. So the first conversion factor, and this is, before we even get into that, I want to talk about the general approach, but you can see that it's asking you, okay, if 2.0 grams of V2O5 reacts with HCl, how much VOCl3 is formed? Now, the thing is, the fact that it reacts with HCl is sort of it's sort of a negligible point that is already stated in the chemical reaction. But the fact that it explicitly states it in the problem statement is sort of unnecessary, because we know that we can make a ratio, a conversion between reactant to reactant. In other words, if we had these two reactants here, if we said, okay, 1 mole, and that's what we have here, 1 mole of V2O5 plus 6 moles of HCl3 or HCl, that's essentially our proportion of reactants. And we can use that to figure out, well, if I were to toggle the amount of HCl from 6 moles to 7 moles, how many moles of VTO5 would I have? Or if I were to toggle the amount of VTO5, how much HCl would I have? Or really what I need to ensure the production consists as it must. But that's sort of a reactant to reactant ratio there. But what you can also do is you can make a reactant to product ratio. In other words, you can say that, okay, 1 mole of VTO5 is 2 moles of VOCl3. And since you have that mole to mole ratio there, that itself is a valid conversion factor, which renders going through the HCl sort of a redundant detail. So you can just say, so we can just make a valid we can establish a valid ratio between moles of VTO5 and moles of the product. In other words, the ratio between the reactant and the product, and that will still give us our answer. It's not asking us anything about HCl3. It's just saying that HCl3, VTO5 has reacted with HCl3. That's fine. But that's really not our concern. Our concern should be, okay, 2 grams of VTO5, V2O5 is how much of VOCl3, right? And the problem statement is very generous, or in other words, the chemical reaction is very generous, because it gives us the proportion in terms of moles of how these compounds are interacting. So what we should do is we should make a ratio between moles of VTO5 and moles of 2VOCl3 And then we can, that's sort of our main goal. Now, some of you may be asking, well, we already have that in the chemical reaction, right? Moles of VTO5 to moles of VOCl3. That's sort of that's picked off from the we already have that in the chemical reaction, but you'll recognize that the problem statement has sort of disrupted. Sorry about that, but really my goal here was to sort of, if some of you are asking why we want to make a ratio between moles of VTO5 to moles of VOCl3, well, the answer to that question is, and you may ask that because, of course, in the chemical reaction, we're already given moles of one compound equated to moles of another compound. It's very evident, but the problem statement has disrupted that. It's sort of imposed, it's brought its own condition. It's saying, okay, you have 2 grams of VTO5. How much VOCl3 is formed? So, we know that in the chemical reaction, 1 mole form of VTO5, results in 2 moles of VOCl3. But now that you have 2 grams, you don't necessarily know how many grams of VTO5 you had in the original chemical equation. The, the problem has sort of interrupted us, and it said, okay, I'm going to throw a random number, 2 grams of VTO5. Now what are you going to do? Well, we have to recalibrate our moles and sort of express 2 grams of VTO5 as moles of VTO5. And then we can express those moles of VTO5 in terms of moles of VOCl3. And then those moles of VOCl3 can be then converted to grams of VOCl3, and that would effectively answer our question. So in order to get to this stage, really, we want to first convert VTO5 to moles, and we need molar mass to do that, because molar mass is that only conversion which can take us to grams of a compound, 2 moles of a compound. It sets up a proportion by itself. And the molar mass of VTO5, if you were to go through the periodic table and sort of take 2 V atoms, which I think has been vanadium or something like that, and then add that to 5 oxygen atoms, and you're adding their atomic weights times 5 times 2 and whatnot. But when you do that, you get 181.88 so grams per mole. So 181.88 grams is 1 mole of VTO5. So that's V2O5. And at this point in the conversion factor, you essentially have moles of V2O5. But remember, our main goal was to express moles of V2O5 in terms of moles of VOCl3. And this is essentially our chance to do that, right? We have moles of V2O5. So what can I sort of what number can I put here and here in terms of conversion factors in order to get from in order to essentially have moles here and moles of V2O5 here and moles of VOCl3 at the top, and so that I can be left with moles of VOCl3 at the end of the conversion factor. Well, you're looking for a multimole ratio, right? Is there anything that is apparent that can essentially equate moles of V2O5 to moles of VOCl3? And the answer is yes. If you look at the chemical reaction, 1 mole of V2O5 is 2 moles of VOCl3. That in itself is your mole-to-mole ratio. And so you can leverage that here. You can say that 1 mole of 1 mole of V2O5 is 2 moles of VOCl3. And so then when you multiply that, you're left with how many moles of VOCl3 happen, right? How many moles were formed of VOCl3. But again, you're looking back at the question, and the question is sort of, it's not asking moles explicitly. It's saying if you have this much of the compound react with how much VOC, it's not explicitly stating what unit of measurement it wants it to be expressed in, but since V2O5 is expressed in grams, why don't we go ahead and also express VOCl3 in terms of grams? So we would need something, and this is sort of our new starting point now. Every time you have something in the numerator, that's your new starting point. How would you sort of move on from this point? Well, you'd have to put something in the denominator and something in the numerator, such that your moles of VOCl3 sort of cancels out, and you're left with grams of VOCl3. And again, that just comes back to molar mass because molar mass helps you do that, right? We know that 173.30 grams per mole for VOCl3. So we can say that 1 mole is 173.30 grams, right? And so what this allows you to do, I mean, eventually is just plug this into a calculator, and it's not confusing in terms of what unit you're left with, because your unit of V2O5 would cancel, and you'd be left with moles of V2O5, and then your moles of V2O5 would cancel. You'd be left with moles of VOCl3, and then your moles of VOCO3 would cancel, and you'd be left with grams of VOCl3, which is what you wanted, right, in the problem statement. And eventually, I mean, really, your answer should come about to being 3.8 grams of VOCl3. So 3.8 grams VOCl3 is formed here.